My name is Pranay Bhavsar. I'm going to present my project, which is hardware implementation of the LeNet Inference engine for the MNIST digit recognition using Vitis HLS. Coming with the objectives. So the main objective of this project is to implement the forward inference path of the LeNet 5 hardware architecture, which will use the MNIST dataset, and the Vitis HLS will be used to implement the hardware design. So the LeNet 5 hardware architecture will use 32-bit precision floating point data type for the computation and for the better accuracy and the hardware efficiency. And furthermore, the hardware design will be validated through synthesis and simulation results, and by providing 10 test input images to ensure the if the hardware design is working appropriately or not. So coming up with the overview of the LeNet 5 hardware architecture. So this is the overall hardware architecture. We will provide the 32 cross 32 input size image to the LeNet 5. So architecture consists of 7 layers, which contains convolution, pooling, and fully connected layers. So uses RLU function with the convolution layer to, so it will predict the read class from 0 to 9. So coming up with the data set. So the dataset contains 60,000 images for the training and test set of 10,000. So size, it contains 28 cross 28, but it will be padded, so its size will increase to 32 cross 32. So here are some labels. It will contain 0 to 5 class digits. So coming up with the methodology. So first I will create a Python script which will generate the pre-trained weights and biases for that. And also it converts images to text file, which will be provided to the HLS. So the weights and bias will be converted to the header files, which will be used for the HLS for the C code. So in the next step, the hardware design will be implemented in C, which will contain the LeNet 5 layers for like convolution, fully connected, and the RLU. And furthermore, the test bench will validate the design of the hardware, which by providing the test inputs and predicted the outcomes. So next is the verification results. So here you can see the verification. So I provided 10 input images to verify the output of the hardware design. So I created the LeNet test C code uh, to verify the design by providing the test input cases. So in here you can see that some of the images are not predicted correctly because of the retained weights, which are normalized to the 0 to 1s only. So it make approx calculation to 0. However, the simulation complete with 0 errors, so it shows that the hardware design is working correctly. So coming up with the synthesis result. So the timing it has max clock frequency of around 100 megahertz. So here you can see that it has uncertainty of 2.17 nanoseconds, and the estimate is 8.424 nanoseconds. So here are some resource utilization of the floating point 32 implementation. So the floating point 32 data type contains too much of computational demands to meet the accuracy. So for example, in DSP, it goes above 600% to which is which is more than the Zybo FPGA board, Zing 7000 FPGA board to meet the requirements. So in future work, it can be optimized the design to meet the requirements. Now I will show my code and run the process to show how it will work. Let me share the screen for the code. So here I implement the hardware code. So here you can see that I implemented each layer. So here is the RLU, softmax, and the convolution layer. Here is the max pooling and fully connected layers. So the main top model is LeNet Predict, and here is the test file, test bench file, which will predict the output according to the input. So I have provided 10 input images to predict the output. So if I start the, here is the header file which will use for the further process. So I will start the runs simulation. So here you can see that it contains zero errors and it will generate the output with the student ID and the true label and the predicted label. So some of the prediction are wrong because of the pre-trained weights, but it can be further optimized for the future work. So this was the overall presentation of my project. Thank you.